welcome back to Calculus. If you are back with us, let me tell you what we're doing, because these two are kind of the extremely difficult ones I did in class. The homework is not as hard as these, but if you want to follow along, these will make the homework seem rather simple. We are going to, in part, find the volume of a cone and a sphere. So if you can do this, you can definitely do the basic cone, the basic sphere. I don't know if I'll get both of these on one video, but I'll at least do the cone one here. This is a problem in the book. It's actually page 464, number 51. I called it example D in my notes. I don't even have the book in front of me here, but it says something like, you have a cone. I'll just draw it. You have a cone, and this cone has a height of capital H. So I guess I could do this. Capital H is the height. The radius is little r. And someone comes along, some bad person, and they chop the top of your cone off. We want to find out, what is the volume of what's left? We all really want to know this. Well, it's difficult to know. Where do they cut off our cone? So we need to know that. Well, let's label this. Basically, they cut off the cone so that its new height is h units. So they cut off, I guess you could say, h minus h amount, but we don't really need to know about that, so don't worry about that. So that's the premise of this problem. How do we even make a cone with what we've been learning? We've been learning how to revolve things around axes, so let's make the good old axes here. And so how do we make a cone? Well, actually, if you think about a cone, if you just look at it from the side, it looks like a triangle, doesn't it? So that's kind of the key. If we take a triangle and we revolve this around the problem is you have a duplicated volume. So really, we only need to look at this region revolved around. So essentially what we're going to do is draw ourselves a, I don't know if I'm going to run out of space here, but we're going to draw ourselves a right triangle. And this is going to be h, so I'm going to label this coordinate as 0, capital H. This is going to be little r, 0, so that's our radius right there. And then someone's going to come along and chop the top off, and we'll label this as 0, lowercase h. And so we're going to find what is this volume in terms of all these abstract letters. So if you were doing just the volume of a cone, you would not have this cut off 0, little h. You would just use the original part of the cone, and you'd revolve that around it. It's going to be pretty simple. So let's set up our representative rectangle. It's since we're revolving around, I didn't say that, we're revolving around this axis. The rectangle must be horizontal because it's always perpendicular. Therefore, we have a tiny y. So you think, oh, this is not so bad. Volume is pi. Your bounds go slicing. I don't know if I really want to draw the slices. I guess I will. The slicing. All these horizontal slices, you're stacking them all up and adding them together. And the stack goes from 0 to little h, right? And we already said this is going to be a dy problem. So you just got to put in the equation, and actually our edge of our rectangle touches the axis of revolution. That means it's actually a disk problem because our inner radius is 0. So all we need to do is write this equation and square it. But we weren't given any equations. So what are we going to do? Let's get rid of this stuff over here. Need this space. Probably need a bigger eraser. Okay, so what are we going to do? We need to come up with an equation. Well, let's see. The line goes through 0h, that's a 0, and r0. What kind of line does that? Well, you need two things to write the equation line. You need a point, we have two of them, yeah, especially like this one because that basically tells you the y-intercept, and you need the slope. So let's find the slope. Slope is change in y over change in x. That becomes negative h over r. So the equation then becomes y equals mx plus b. M is negative h over r. Our x is x, and our y-intercept was given as capital H. There we go. That's the equation. So we just plug that in here and square it. Problem is that equation is in terms of x, not y. We need to be in terms of y. So no big deal. We just rearrange this. I'm going to throw the h over r on this side. Okay, so it's h over rx, and that will be equals. Wow, this is hard to read. H over r times x equals h minus r. Sorry about this, running out of space. I want to solve that for x, so I'm going to multiply both sides by the reciprocal of that fraction in front of the left side, r over h times h minus r. And then I can simplify this when you distribute that through to be r minus... Hang on a second, is this right? Okay, sorry, I made a little mistake here. Back at this point, I'll try to fix this. Back here, that's a y, right? I tried to subtract on both sides. I made it an r. That doesn't make any sense. Let's change that to a y. That's going to change this to a y. And that then should make this work better. Let's use a different color so you can see it. So it's going to be h minus y, and now when you multiply this through, you have r over h times y. Okay, so this right here, my marker will let me look at it. Okay, there we go. That is our equation we're going to plug in. So it becomes, let's go back to blue. We plug in r minus r over h times y, and we square that. I don't think I'm going to do this integral, but you can't do this in your calculator. You have to do it by hand. I'll show you the answer on the next page, maybe. And we'll go ahead and do it. This won't take that long. Okay, so I'm going to go ahead and simplify. So we have 0 here, we have h here. And once you square that out before you integrate, you better do that. It becomes 2r squared over big H plus r squared over big H squared y squared. Okay, let me check. Sorry, I realized I had a problem with my key, so that was my delay there. So you notice I've erased some things. So I'm back to r squared minus 2r squared over h, and I left off this y here. So y plus r squared over h squared y squared dy. Okay, that should be right. So you notice we have a constant, a linear, and a quadratic term. So we can integrate. This is going to be 1/3. Oh, whoops, not 1/3. This is going to be, because our variable we need to look at is y. So r squared is a constant. You know what? I'm just off my game here. I apologize. I just did this twice today, and this is my worst one. Let's factor out that r squared before we carry on. That's going to simplify things greatly. Everybody has an r squared. R is a constant, just like the h's, so they can be pulled through the integral without any questioning. So that gets us here. Notice I'm keeping the y out front like a variable to help remind me, although it didn't really work that well here, what my variable integration is. I'm ready to integrate now. So pi r squared, this becomes y minus 2 over h times 1/2 y squared plus 1 over h squared times 1/3 y cubed, evaluating that at h and 0. Okay, getting close. When you plug this in, it's really nice. Those 2's are going to cancel, by the way. You just replace your y's with h's. So this is going to ultimately become little h squared over big H plus little h cubed over 3 big H squared. And then we plug in 0, they all go to 0. The one thing we could do that might be reasonable is factor out an h. Why not? So this will be our final answer. Pi r squared little h, parentheses 1 minus little h over big H plus little h squared over 3 big H squared. And that's as good as it's going to get, at least I think. Let me double check everything. Yes, that looks right. Okay, hope this helped you out. I'm going to try to do put one more up here today.
Made with Doodlecast Pro.